What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet, and today we're continuing our probability series, where in this video we'll talk about calculating conditional probabilities using a two-way table. If you're just getting here now, make sure you go back and watch my previous video. I'll leave a link to that in the description below. In that video, we introduced calculating probabilities using a two-way table, so it's a very nice intro to the work we're doing today. But for now, let's jump right into it. We had defined probability as the likelihood that an event occurs, and we write that as the probability of event A, regardless of what event A is. It could be the probability that the Giants win the Super Bowl. It could be the probability that we get an A on our test. It could be the probability that it rains tomorrow. Conditional probability is a different type of probability, and it has that word condition in it. Conditions have influences on probability. For instance, imagine the condition that maybe a parent has for you, which says that they'll let you get a PlayStation if you get an A on your test. That is a condition of getting the PlayStation if you get an A on your exam. Well, conditional probability works very similarly. It tells us how likely an event occurs given on another event has already occurred or already happened. The key word here is given. For instance, when we're just looking at probability of a single event, it could be the probability that the Giants win the Super Bowl. Where the probability of a conditional event would be what is the probability the Giants win the Super Bowl given they win 10 games in the regular season. You see that there's a condition there, and it's given that the Giants won 10 games in the regular season. When we look at conditional probability notation, it's different than regular probability notation in that you can see there's two events, A and B. The one that gives the condition is the second one, and there's a slash there. But we won't talk too much more about notation in this video. This video is all about two-way tables. In our last video, we defined a two-way table as a frequency table that has data that corresponds to two different categories. In this example, the two different categories are Instagram and Snapchat, corresponding to the students that use both of these apps, one of these apps, or neither of these apps. We define the entries within each table as a joint frequency. Those would be these four entries here. We defined the sum of the rows and columns as marginal frequencies. Those would be these four pieces of data here. And of course, this would be the grand total. Let's jump into an example today to learn a little bit about conditional probability. The two-way table below shows the number of students at New City High School that passed the test and completed the homework due the day of the test. Part A. What percent of students passed the test and completed the homework? Round your answer to the nearest percent. Part B, what percent of students passed the test given that they completed the homework? Round your answer to the nearest percent. I designed this problem to show you the difference between a regular probability of a single event and the probability of a conditional probability. If you look at Part A and Part B, they read very similar to one another, but in Part B, you can see that it has the word here, given. Whenever you see given, that's going to indicate that we have a conditional probability. Part A is the probability of a single event, much like we did last time. It says what percent of students passed the test and completed the homework. Well, first we want to find the number of students that passed the test and completed the homework. That's these 10, out of the total number of students, 26, and that would be our exact probability. Here they want it as a percent, so first divide to make it a decimal, then multiply by 100 to make it a percent, and rounding to the nearest percent, 38% of the students at New City High School passed the test and completed the homework. Part B is quite different. It's our first example of a conditional probability. What we want to know in Part B is what percent of students passed the test given that they completed the homework. In this case, we don't want to know about all of the students. We only want to know about the students that completed the homework. So if we only want to know about the students that completed the homework, these 13 students here, we don't care about any of this information for this problem. Now, of these 13 students that completed the homework, how many of them passed the test? Well, 10 of those 13 students passed the test given that they completed the homework, so that probability is 10 out of 13. Notice the conditional probability has changed the whole group that we were looking at. In Part A, we were looking at all of the students. In Part B, we're only looking at the students that completed the homework. Now, of course, we have the exact probability, but we want it as a percent, so start by dividing to make it a decimal. multiply by 100 to make it a percent, and rounding, we can see that 77% of the students passed the test given that they completed the homework. Let's look at a couple other alternative wordings that they could use to represent conditional probability. In part B, they used the word given to indicate conditional probability, but there's other ways we could have asked this very same question, but just using some different wording. Another alternative way to ask this would have been to say what percent of students who completed the homework also passed the test. Notice here that we're not looking at what percent of all students, we're looking at what percent of students who completed the homework. That clues us in that we're only interested in the base of the students that completed the homework, because again, it didn't say what percent of all students, it said what percent of students who completed the homework also passed the test. We could have also asked this same statement here without the word also. The word also is definitely helpful to letting us know that it's a conditional probability, but they could have asked the same thing like this: what percent of students who completed the homework passed the test? Another alternative way of asking the same question would have been to ask it like this. They could have said, if a student who completed the homework is chosen at random, what is the probability they pass the test? Notice here we're picking a student at random, and we're not picking any student. We're picking specifically a student who completed the homework. Again, we're picking one of these 13 students, and of those 13 students, which one passed the test? Let's move on to see if you can answer one of these conditional probability questions on your own. The two-way table below shows the number of students at Gramercy Arts High School that use Snapchat and Instagram. What percent of students use Instagram given they use Snapchat? Round your answer to the nearest percent. We can see this is a conditional probability because it uses this word given here. That's a big clue. It says what percent of students use Instagram given they use Snapchat. So here we're really only interested in the students that use Snapchat, which is these 52 students here. We're not going to care about any of this data here for this question because again, it says what percent of students use Instagram given that they use Snapchat. When it says given they use Snapchat, that is the condition that we're looking at. Here we can see that 52 students use Snapchat, and of those, how many use Instagram? 34 of those 52 use Instagram, so that would be our exact probability. Of course, here we want it to the nearest percent, so divide to make it a decimal, multiply by 100 to make it a percent, and rounding, we can see that 65% of the students at Gramercy Arts High School that use Snapchat also use Instagram. Let's try another example. In a class of students, the following data summarizes how many students have a cat or a dog. What percent of students have a cat given they have a dog? Round your answer to the nearest percent. Here we can tell this is a conditional probability right away because it has this word given. That's a big clue. It says what percent of students have a cat given they have a dog. So it's not what percent of all students have a cat, it's which students have a cat given that they have a dog. So first thing I want to do is find the students that have a dog. These students here said yes, they have a dog, these 14 students. I won't care about this data here for this question. I can see that 14 students have a dog, and given this, 5 of those students have a cat, which makes the exact probability 5 out of 14. Now we just divide to make it a decimal, multiply by 100 to make it a percent, and rounding here, I can see that 36% of students have a cat given that they have a dog. Let's try another example. The two-way table shown below shows the number of students at Brooklyn Tech High School that own a PlayStation and/or have used TikTok. What percent of students use TikTok given they do not own a PlayStation? Round your answer to the nearest percent. In this question here, I can see that they only gave us the joint frequencies, but we're missing the marginal frequencies, so I'm just going to add those to the table. Let's start by summing the rows and columns. I'll start by summing this first column. 10 plus 14 would be 24. That's the total number of students that own a PlayStation. 25 plus 40 would be the sum of the next column. That would be 65. That's the total number of students that do not own a PlayStation. Now let's sum the rows. Let's first find the number of students that, yes, they use TikTok. 10 plus 25 would be 35. And finally, let's find the number of students that don't use TikTok. 14 plus 40 is 54. To find the total, we have 3 ways to do that. We can either add these 2 frequencies, we can add these 2 marginal frequencies, or we can add these 4 joining frequencies. 24 plus 64, or sorry, 24 plus 65 looks like it would be 89. I can check that 35 plus 54 is 89, and it does, so I didn't make a mistake. Now let's go back and look at the problem. I want to know what percentage of students use TikTok given they do not own a PlayStation. Seeing that word given clues us in that this is a conditional probability, and it says given they do not own a PlayStation. So I don't want to know about all the students, I only want to know about the ones that don't own a PlayStation. Well, here's PlayStation and here's no, so I only care about these 65 students. I will not care about the ones that own a PlayStation, and I certainly don't care about the total number of students. So of these 65 students, how many of them use TikTok? It looks like 25 of those 65 students use TikTok. To change this exact probability into a percentage, we're going to first need to divide to make it a decimal, multiply by 100 to make it a percent, and then round. I can see that 38% of the students at Brooklyn Tech High School use TikTok given that they do not own a PlayStation. Let's try another example using this same data. In this problem here, what percent of students who use TikTok own a PlayStation? Round your answer to the nearest percent. We found the marginal frequencies in problem number 3, so let's just fill those in here. Now let's look at the question. What percent of students who use TikTok own a PlayStation? Well, I don't see the word given here, but it's still a conditional probability. It's just a different way of wording it. They didn't say what percent of all students. They didn't say what percent of students at Brooklyn Tech High School. They said what percent of students who use TikTok. So the only students I'm interested in here are the ones that, yes, they use TikTok. It looks to me like that's this 35 students here. Of those students who use TikTok, how many own a PlayStation? It looks like 10 of those 35 students own a PlayStation, so the exact probability here is 10 over 35. To make it a percent, let's first divide to make it a decimal, multiply by 100 to make it a percent, and rounding, I can see that 29% of students who use TikTok own a PlayStation. Let's try another example. Data collected about exercise from students who live in Queens and Brooklyn is shown in the table below. What percentage of students live in Brooklyn and like to exercise? I can see here that we only have the joint frequencies and not the marginal frequencies, so let's fill those in together by adding. Adding the first column, 13 plus 3, I can see that there's 16 students that live in Queens. 7 plus 18 would be the sum of the next column. That would give us 25. That's the number of students that live in Brooklyn. Let's find the sum of 13 and 7 to find the total number of students that like to exercise. 13 plus 7 is 20. Let's find the number of students that don't like to exercise. 3 plus 18 is 21. And we can find the total by either adding these 2 marginal frequencies, adding these 2 marginal frequencies, or summing these 4 joining frequencies. When we do that, we should get 41. Now we need to decide if this is a conditional probability. First, I look for the word given, and I don't see it. So that already means that it might not be a conditional probability. And then I look at what group I'm looking at. Well, here it says what percent of students. It doesn't say what percent of students who live in Brooklyn. It just says what percent of students. So here I'm looking at 41 students. This is not a conditional probability. And what percentage of those 41 students live in Brooklyn and like to exercise? Well, I can see that these 7 students live in Brooklyn and like to exercise. Notice this problem didn't say what percentage of students who live in Brooklyn like to exercise. It says what percent of students live in Brooklyn and like to exercise. That's just a regular probability. The exact probability here is 7 out of 41. Dividing to get the decimal, multiply by 100 to get the percent, and I can see that 17% of students live in Brooklyn and like to exercise. Let's try one final example using this same data. In problem number 6, I want to know if a student who does not like to exercise is chosen at random, what is the probability that they live in Queens? In problem number 5, we found all of the marginal frequencies, so let's just fill them in here. Now we want to decide, is this a conditional probability? Well, I certainly don't see the word given anywhere, so I want to look, am I looking at what percentage of all students, or am I looking at a subset or a smaller group of students? Looking here, I said if a student who does not exercise is chosen at random. It doesn't say if a student is chosen at random. If a student was chosen at random, I'd be looking at all 41 students. But here I'm only looking at a student who does not like to exercise. So here are the students that said no, they do not like to exercise. It looks to me like I'm looking at these 21 students. Of these 21 students who do not like to exercise, what is the probability that they live in Queens? Well, I can see of the students that do not like to exercise, only 3 of them live in Queens. So the exact probability is 3 out of 21. To find the percent, first divide to make it a decimal, and then multiply by 100 to make a percent. And I get 14%. So if a student who does not like to exercise is chosen at random, 14% of them would live in Queens. Well, that's it for this video, and that's it for me. I hope in this video you learned about what conditional probability is and how you can find it using a two-way table. Until next time.